to demonstrate how you can solve a model and solve dynamic decision problems, I'm going to use the following example. Magnolia is a hotel chain that is planning to build a new hotel near a new airport. However, the authorities have not yet decided where the new airport will be. All we know is that there are two possible locations and that the airport will certainly be built in one of those two locations, but the decision will not be made for some time. And land values around both possible sites for both possible locations for the new airport are increasing as investors speculate that property values will increase greatly in the vicinity of the new airport. And for now, I'm going to ignore the last point, which is the one about probabilities. You see the data of this problem in this table here. So we have two parcels of land that we identified. One is near location A of the airport, potential location of the airport, and the other is near location B, which is another potential location. Currently, we can buy the parcel for $18 million near location A and $12 million near location B. And we have done a lot of analysis to determine present value of all future cash flows if a hotel and the airport are built at the same location. So if we choose location A and the airport is actually at location A, the present value of all future cash flows will be 31 million plus 31. So we will actually make a nice profit. However, if the location A is not chosen and we invest in 18 millions, then all the present value of all future sales price of the parcel will be only 6 million. So we will have a significant loss. And similar values here are provided for location B. So the first thing that we need to understand here in order to try and model this problem is what kind of decisions are available. So the obvious thing is that we need to decide whether we buy land at some parcels or not. But what are exactly our options, right? So we need to list those exactly. So let's say I will put here, I'm going to scroll a little bit here and start a table, and I will say land purchase at location, right? And so of course I can buy land at location A, or I can buy land at location B, right? And it seems that there's one more obvious option which I'm going to choose, which will be also buy neither, right? Or none of the locations. Let's just put none, right? But there is one more option that you might realize is that maybe it's very expensive, but at the same time, maybe it's a valid option that we should consider, which is buying on both locations, A and B. So let me first list A and B as one option and none. And I hope you will see that assuming that the company has enough funds, we could actually buy both locations for a total of $30 million. And then hopefully, right, I mean, one of those locations will be chosen, in which case if it's A, we'll get this. And for location B, we'll only get salvage value of 4 million. But if it's B, we'll get this. And here salvage value. And perhaps this option will be attractive from a certain perspective. So these are our land purchase decisions. This is a single decision. Let me just format this a little bit. And then, right, and then we have to see what are we going to be affected by. And the value that we will obtain at the end of this decision problem will depend on our decision, but also it will depend on the location where the airport is built. So I'm going to just say here at the top, airport is built at location, and it may be A or B, right? And I hope you see that that this is what is going to affect our payoff, and in fact now our final payoff will depend on both of those. Our decision, which comes first, And right, because these prices are now, the land will be much more expensive later. So it's we're not considering buying later. And then this event, which is uncertain. This kind of problem is sometimes called a game against nature, because the airport location is not going to be chosen to please us or to punish us. Right? It's if you compare it to, for example, a game of chess. In a game of chess, you play against an opponent who wants to win, and the winning of your opponent means you will lose. So your opponent will make the worst possible moves from your perspective for you, right? Those moves that will hurt you. On the other hand, when you play, when you have a game against nature, as we call it, you play against something that does not favor you or does not try to punish you in any way, right? So it's like a rain. It rains just because it rains. It doesn't rain in order to make you wet, or it isn't sunny just in order to make you feel warm. It just happens randomly. And in this example, we will also assume that the airport is built at location A or B randomly, and it's not affected or is not correlated in any way to to the decision that we are taking. So to complete the payoff table, we have to actually determine the actual payoff values. So we now need to realize what will happen if I make a decision to buy land, right? And let me change this at location A, and the airport is built at location A. What will be the total value, present value of future cash flows or current cash flows that I will have? And I hope you see that we will get 31 million, because this is the right location that afterwards we will recognize in this one possible final situation, minus 18. So we'll get 31 million minus 18 million of cost that we currently incur. So we will get 13 millions. However, if this is the case, if we buy at location A and the airport is actually built at location B, then we will get only 6 million, right? It's a wrong location. We bought A, but airport is not at this location. We only get 6 million. And of course, we paid a negative 18. So our payoff is negative 12, indicating that this is a loss of $12 million. The same logic we can apply to location B. Let's start here from this, right? This is a successful move. If we buy at location B, we obtain, and the airport is at location B, the future cash flows will be plus 23 million minus the cost of purchasing location B, which is 12, right? So we'll get 11 million. And this one, we buy at B, but the airport is not near location B, it's near location A. So we will actually get only 4 million, and our cost is 12 million. So again, it's a negative one. So you see, it's a risky game. We can actually lose a lot. Now let's see both locations, A and B. So to realize what the cost will obviously be both of those, right? In both cases, we purchase both locations A and B, so incur cost of both. But what are the profits? So here, if we have both locations, we will get both, right? When the airport is at location A, we get 31 million just for having parcel at location A, and we get 4 million for having parcel at location B, which is the wrong one. And we subtract the cost 18 and subtract cost 12, right? So I basically combine 4 numbers here, 2 revenues and 2 costs, right? And then, so this is 5 million. And then in this case, the location B is the right location. So I get 23 millions for location B, and I get 6 million for location A only, and then I subtract 18 and subtract 12 again. So here we get a loss of 1 million, right? So this is actually a much less risky option with, of course, a higher initial investment. So this assumes we have enough credit or capital in order to purchase both pieces of land, but it is much less risky at best. In the worst case, we will lose $1 million. And if we buy neither of the locations, right, the actual value is 0. Let me just center those. All right, so you see, so basically this table summarizes our options. The decision that we have, the decisions are here in rows. There is 4 alternatives you have to choose: A, B, A and B, or none. And the chance that will affect us is where the airport will be built, at location A or at location B. And then you see both of those will affect what value we get. If the airport is at location A and we chose B, we'll get -8 and so on. We can describe every possible situation here. So this is the payoff table. Let's actually write here, payoff table. Right, the payoff table inside the numbers denote how much value each of those options provides, the payoff of each decision chance combination.